All right, here, folks. Today, Chapter 3. We started Chapter 3 last class. We did sections 1, 2, and 3. We'll finish Chapter 3 this class with Section 4. Next class will be the Chapter 3 quiz. The following class will be the Chapter 3 test. Yeah, we're just ripping through stuff right now. I know.
How many more chapters do you want to get through before the end of the year?
3. Huh? The IB exam?
Yeah.
Not totally sure what the date is.
Is it multiple choice?
Nope. I'll give you guys a practice one at some point to see what it looks like.
Right?
No, not my intention to grade it.
I mean, you can grade it, but maybe not in the
Yeah, whatever. We'll do something with it. I'd heard through the grapevine that a couple of us had questions from the Chapter 3 homeworks, which seems like a good place to start, as it'll allow us to kind of do a little bit of review along the way for those of us that missed the previous Chapter 3 lesson. Isaac or Diego, I heard you guys have numbers?
Yeah, number 2, letter E.
From section 3?
Yeah, section 3.
Okay. What do we... That's fine.
Number 2, letter E. Section 3.
This is the problem, right?
Yeah.
I don't know why it's blue for me. I did something dumb. All right, let's see. 2E part 3, is that correct?
Oh, yeah, sure. Yeah, we can do that.
What?
Yeah.
Yes? Okay. So, notice the sequence that's defined here. Is a little unusual, right? This is what we call a recursive sequence. So what I'm noticing that's happening is I'm just taking the previous term and multiplying it by 3. So each time going from term 1 to term 2, we multiplied by 3, which tells us what type of sequence do we have here?
This is geometric.
It's geometric because we're multiplying each time. So we know U1 is 4. What's U2 going to be?
12.
It's 3 times the previous term, so 12. And U3 would be 3 times the previous term, so that's 36. And you can kind of continue doing this. The numbers are starting to get obnoxiously big. Alternatively, we could take this recursive definition that we're given and turn it into an explicit definition. So remember that that's our explicit formula for a geometric sequence. And I'm given the first term. I don't know why I wrote an A there. That should be a U. Come on, pencil. Do erasing form. There you go. So that'd be 4 times 3, which is my R to the n minus 1, which will probably be more convenient. So if I want the 10th term then, should get that. And I'd be fine with you leaving it this way. If you type in your calculator, it's probably going to do I don't know, did it overflow your calculator? I guess probably not. 3 to the 9th isn't that big. It's big, right? 4 times 3 to the 9th is 78,732.
Okay. I wasn't sure if it was geometric or.
Oh, okay. Yeah, that's how I'm telling. It's just that like each time I'm multiplying by 3. If the constant of change is a multiplication problem, it's geometric. If it's an addition problem, it's arithmetic. Cool.
Yeah.
Okay. Who's up next? Do you have more? Isaac, you got one?
13 or 12 on 3.3.
13 or 12? Probably can do both. Okay. Which term of a geometric sequence that starts 6, 18, 54 is 118,098? Okay. So I noticed that constant ratio here is 3, right? We're multiplying by 3 each time. So the dumb way we could do this so that's my first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term, 10th term. You could do it that way and just like brute force it with your calculator. It's not so bad, right? Or you could say, okay, well, I'm going to write the equation, and for u sub n, I'm going to plug in 118,098 and try to solve this for n. So I'd want to start by dividing both sides by 6. So that's 19,683. And then how do I get a variable out of an exponent like that? What do I need to use? I need to use a logarithm. Very good. Which logarithm should I use for this problem to make it as easy as possible? I want to use log base 3. I want the base of my logarithm to match the base of my exponential. You don't have to do it that way, but gosh, it makes it like way nicer. Actually, let's, oops. Oh, come on, you stupid eraser. Some days this eraser just doesn't want to erase for me, and I don't understand why. So, and then I'll just add 1 to both sides. And type this into my calculator. So to get the log base 3 into your calculator, if you press the math button and you scroll down to the very bottom, there's the log base command. If you choose that, it lets you type in any number as your base of your logarithm. I shouldn't say any number. You can't do a negative, you can't do 0, but like, but it lets you pick that number. And then we just have the +1 at the end, and bingo, bango, bongo, there's our number 10. Either way of approaching it is fine. You can brute force it You know, like just type in your calculator and just keep multiplying by 3 till you get the number you want and count how many times you had to do that multiplication. That's not bad, particularly if it's a reasonably small number. Now, if it was like an arithmetic one, I might be a little dubious there because you might have to press, you know, that add 3 like 10,000 times and you can still have a pretty doable problem. That stinks. For geometric, they're probably not going to have you, you know, have to press enter more than like, you know, 10 or 12 times because just the numbers are going to get too big. Overflow your calculator kind of thing. Does that feel okay? And 13, slightly different problem. We'll do that one too. So it says the fourth term of our geometric sequence is 18. And the seventh term of our sequence is 729 over 8. And it asks then, is this guy a term in our sequence? Right? Is there some k that'll give us this specific term? So the way that I'm going to approach this is I'm going to take these two together to create a u sub n. Okay, with that plan? So I know that my u sub 4 is 18. Everybody's okay with that? So if I plug in 18 for u sub n and 4 for n, I have an equation with two variables, u1 and r. And I can do the same thing then with my other and that's going to create like a system of two equations. Everybody's okay there? I'm going to think about this first one as equation A and the second one as equation B. Now notice here, when we solve systems in Algebra 2, we used, to do elimination, we added or subtracted the two equations together. But that's because the variables were being added or subtracted together. Notice here the variables in my equation are being multiplied. So to do elimination here, I need to divide. So I'm going to take equation B and divide it by equation A. In general, I want to pick the numerator to be the one with the bigger exponent. Just makes life a little bit simpler. It's fine if you don't do that, but you know, my life is hard enough. Let's not make it more complicated than it needs to be. So if I do that, I'm going to have 729 over 8 divided by 18 equals u1 r to the 6th over u1 r to the 3rd, right? Well, the u1s reduce, and r to the 6th divided by r to the 3rd is just r to the 3rd, because we subtract exponents when we divide. And then let's just do 729 over 8 divided by 18 real quick. So that's 81 over 16. And then I need to do the cube root of both sides to get r by itself. Cool with that. Now, could you simplify this a little bit? Yes, but I'm not going to worry about it because that's not the question it's asking for. It's not asking me for the equation for A or for UN or what the R is. I'm just like, this is going to be a step along the way, and I'm not going to worry about simplifying it because it doesn't matter. It's just going to be a place for me to make a mistake. So I'm going to skip doing that. Is everybody okay? All right, so I still need my U1. To do that, I'm going to take my value for R and plug it back into one of the two equations. I'm going to plug it into the first one just because the numbers are a little bit smaller. So there I have 18 equals u1 times the cube root of, oops, not 18, but 81 over 16 to the third. Well, that's convenient. So the cube just cancels the cube root. So I'm just going to multiply both sides by the reciprocal. So I have 16 over 81 times 18. And again, I could simplify that. I'm going to skip doing that because, well, it's just like a place for me to make a mistake. And it doesn't really matter. So far, so good? All right. So what I have then is u sub n is 18 times 16 over 81 times the cube root of 81 over 16 to the n minus 1, right? And I want to solve that for 59,049,128. I want to solve that for n. Yuck, right? Doable. So we'll divide both sides by this guy. So I'll have 81 over 16 times 18 times all this stuff. Oops. Right? And we'll do the log. And we'll add 1 to both sides. And I think probably everybody's like, ugh, Mr. Kulik, I cannot do this. Here's the good news. You ready for the good news? Your calculator will do this all for you. Yep. Let's show you the easiest way to do this. If you have your calculator with you, I invite you to take it out and follow along because this will be potentially quite useful. So I'm going to go back to the very beginning part of this problem. And I'm going to look at this piece right here. Instead of thinking about that as two terms of a sequence, I'm going to think about it as 2 points, where the x-coordinate for the first equation is 4 and the y-coordinate is 18. And the x-coordinate for the second equation is 7 and the y-coordinate is 729 over 8. Is everybody okay with how I'm seeing that? All right. So I'm going to go press stat. That's right next to the left-hand arrow. From that edit command or edit tab, I'm going to pick the edit command. I'm going to clear out anything that I happen to have in L1 or L2. And I'm going to type in 4 and 7 as my x's. And then 18 and 729 over 8 as my y's. Everybody's okay there? And I'm going to exit out of here. So remember we talked about geometric sequences. We said those are just like what kind of function? Exponential. So what I'm going to do is I'm going to ask my calculator to create an exponential equation that passes through those 2 points. So I'm going to press stat. I'm going to go over this time to the calc tab and scroll down till I find the exp reg, so exponential regression function. and I'm going to select that. So I'm going to tell it I'm going to use my x's are in L1, my y's are L2, and I want to store the regression equation that we're going to create. I'm going to store that into Y1. So to get the Y1 there, we press vars, right below the down arrow. We go over to yvars, we pick function, and then there's the Y1, and then we hit calculate. So this is my regression equation that the calculator's come up with. Does everybody get the same numbers? Doesn't matter if you got the r's and the r squareds or not. The key there is the r squared is equal to exactly 1. So let's look at the graph here right quick to show you what we did. Did you get it to work?
I don't have the R's.
That's okay. We'll get them in there later. If you remind me, I'll show you what to do to get those. Does not matter for what we're doing right here. But before you take the IB exam, you'll definitely want your R's on. Okay. So I'm going to do zoom, and then I'm going to pick stat. So here's my equation, or the graph of my equation. Those are the 2 data points that I used to build it. Notice it's like a perfect fit. Now what I want to do is I want to see where y equals 59,049 over 128 intersects this thing. So I'm going to go into my y equals, and I'm going to change this to 59,049 over 128. Everybody's okay there? And before I hit graph, I'm just going to see what that number is about. So 461, okay. All right, so I hit graph, and I notice that that line that I just made, 59049 over 128, isn't on my graph, right? Oh no! What I'm going to do is I'm just going to change my window. So remember, we just typed this into our calculator, so like 461. So I'm going to change my Y max to be like 500, something bigger than 461. And I'm going to hit graph now. Oh no, it's not intersecting. Which way do I need to move my picture so that we'll be able to see the intersection? Left, right, up, down, to the right. So I'm going to go back to my window. I'm going to change my X max. I don't know how much to change it by. I'm just going to about double it. I'm going to go to like 15. Was that 7.3 for me? That's probably enough. Oh yeah, it is. And there's my intersection there that I'm going to be looking for. So I'm going to do the intersect command. So I'm going to press second and trace. Do intersect, enter, enter, enter. And the X value I got is 10. What is that telling me? That should be the 10th term. So is that a term of the sequence? Yes, it's the 10th term. What if my X was like 9.7? It's not a term of the sequence because it's not a whole number. Should we do that again? Okay, let's see, is there another one? Yeah, 14's like the same problem, right? Let's put 14 up here and ask you guys to do that. Just use your calculator to do it. So try it on your calculator right now. try to do 14 on your calculator, just like we did it. If you need to borrow a calculator, I got a stack up here. That's totally fine. You don't even need to have to ask. Luke knows the deal.
Yeah.
It's like he hasn't had a calculator all year or something.
I mean, I went at home.
Yeah, I got it.
Oops.
What is our quiz on? Is it on 3-1 or is it on 3-2? Both. Oh. Or 4.
Yeah, we'll talk about it in just one quick sec. Is this what you guys got?
Yes, absolutely. No.
Did I get the wrong thing? Did I type something in wrong? Oh, sure did. Look at that. I got an extra number back there.
And just charged. Wow. I was like,
This
is up there. I was like, oh my god, Mom, like you're entering like Delta Zeta.
Yeah, there it came.
Oh, there we go. She is very.
Does that process feel a little bit more doable than doing it purely algebraic?
Yeah.
For the IB exam, all they care about is an answer. Well, what I would tell you is if you have the correct answer, that's good. If it's not correct, well, it's like assigning partial credit for something that there's no work shown for is difficult. So like, give me something, even if it's just, like, okay, I use these 2 points to create the equation. Here's the equation. Then I plugged this into this spot and solved it. This is the answer I got. So at least like it tells me you understand the process. That way I can assign some partial credit, even if you fat fingered something on the calculator and you get the right answer.
And I'm making that.
Yes. Yeah.
Which is just explaining nonsense to just explain what you did wrong. Because like there's so many times where I'm just like, oh, I knew this answer wrong. Oh, I was like, everything here is wrong, and I'll tell you why it's wrong.
All right. We feel good or better anyways? Okay. Figured there was, like I started doing it, I looked up and nobody looked very happy with what I was doing. You're all like, oh my God. It's like, okay, we can make this easier. Let's find a way to make this easier. All right. If this was the same problem, but we're dealing with arithmetic sequence instead of geometric, what's the only thing that has to change with the calculator process we've just described? Instead of using exponential reg, we use lin reg. Everything else would be the same, though. Right? The only change that need to make. Great. Other homework questions? I think this is the single hardest type of question from the homework was one of these. But if you have the calculator hack, now it's like, okay, this is eminently doable for me. Need to practice the process maybe a couple of times, but it's not like we're using commands we've never used on the calculator. We've used all these commands a bunch of times, right? So, okay. Great. Let's talk about 3-4 then.
I don't think you know.
3-4 is about series. So a sequence looks like something like this, right? A series, I would say multiplying by 1/2 is the way to think about that, but yes, that's. So a series looks like this. What's the difference? Yeah, we're adding the terms instead of just writing a comma between them, right? So say I just wanted to add up the first like 5 of these things. We call that a partial sum. So the subscript on your series notation tells you how many of the terms we're adding up. So S5 tells you add up the first 5 terms. If it was S12, you'd add the first 12 terms. If it's S2, we add up the first 2 terms. Everybody's cool with that? So if our sequence that we're adding up is arithmetic, guess what we call the series? Yeah. And if the sequence is geometric, guess what we call the series? Take a guess. Somebody other than Diego.
Geometry.
Oh my gosh, you're so smart.
Ooh.
Okay. Oftentimes when we talk about a series, we want to find a compact way of representing that. So let's say we have some series S, and the partial sum S sub k is the first, or is the sum of the first k terms of this sequence A. We might also rather write this using summation notation. So underneath the summation symbol, we're going to name a variable that we're going to use to indicate the term number. What term number do we start this summation with? 1. And what term number do we end the sum with? K. So this should be the sum of 1 to k. And then my sequence that I'm adding up, well, was named with A's, and the subscript should match the new variable that I've introduced. Everybody's okay with that? So those two things mean the same thing. Is everybody cool with how to read that symbol? We've seen that symbol before when we've done statistics. So that's not a new thing. That letter I is what we call the index of summation. And the 1 would be like the lower limit. And the k would be like the upper limit. I don't know if they use that vocab in the homework or not, but let's go ahead and introduce it. All right, let's do some examples, yay? Just to practice this notation. Oops, that was too much. I clipped too much. All right. For part A, it says our instructions are to write each series in full. So how do I write this first one? My variable is I, right? What am I going to be plugging into I? The numbers 1 through 5. Is that okay with everybody? So again, all I care about is the I, and I'm just plugging in the start and the end. All right, who can do part B for me? Tell me what to write. Mm-hmm. But
Oh,
mm-hmm.
Oh, that. Okay.
because the R is what's changing, right?
Like not created R.
So R is taking on the values from 3 to 7.
Oh, yeah.
So I'm taking wherever the R is and I'm starting with 3, plugging that in, and then just doing plus, and then plug 4 in, plus 5 in, yada, yada, yada. Ooh, look at this fun one. All right. What is our index variable? J. So there's 2 places to plug in J, right? What do we start plugging into J first? 1. So I'd have x sub 1, p of x sub 1. Right? What's the next thing I plug in for J? What comes after 1? 2. And then the next thing after that I plug in is? And how long do I have to do this? Plugging into. Where do I stop? So I stop when I get to n. So let's just do plus dot 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 plus the last one. Everybody feel okay there? Yeah? We're okay? All right, let's do another. Just getting comfortable with our notation here. So here the directions say evaluate. What does evaluate mean? Like figure out what the number equals, right? So how am I going to do that?
To add them up. So we start with the first two, which is the 2 0 plus 2 0 2 0 2.
And what are these? Everybody's okay with what we did there? Can I show you something on your calculator? If you have your calculator with you, I invite you to take it out and turn it on and follow along with me right now. That process that we just did there by hand, guess what? Your calculator can do that too. Let's show you how. I'm going to start by pressing the math button. I'm going to scroll all the way down to the bottom until I find the summation command. So I'm just going to kind of type this problem in the way it looks. Instead of using n's, I'm going to just use the x. So I'll do x equals 0 to 5, 2 to the x, enter, 63. Should you ever do this by hand? No, use your calculator to do it. Isn't this lovely? Your calculator is such a nice friend. All right. You should get to know your calculator, invite it out to a nice romantic dinner, ask it questions about itself, right? Get comfortable together.
My calculator's cheating.
All right. Here it says to take this sum and write it into sigma notation. This tends to be a little more challenging. All right, so we're going to need something that looks like this, right? Inside my summation should be a sequence. The variable this sequence should depend on is I, right? So who is surprised that when I write my sequence, I want to write it with a fraction in it? A fraction bar. Is anybody surprised at this? You don't know what to think? Well, look at the terms of my sequence, right? They're all fractions. Everybody see that? So I want my sequence to look like a fraction. Everybody agree with that? Let's look at the numbers in the numerator and denominator of each term of my sequence. What do you notice? The numerator is one more than the denominator is one more than the numerator, correct? So I would do like that. Right? Is everybody okay with that idea? Now, for my series, what number should I start with? 1. Because when I plug 1 in, for I, it needs to be the numerator of the very first one. Everybody agree? What should be the last, or what should be the number my series ends with? 99. That'll do. Is this the only way you could do this? No. I mean, you could do something like insane and do like something like that, where you need to start with -2 and end at 96. But like, you could do that. I don't know why you would. But like, there's infinitely many answers to this question. I'm sure the back of the book won't represent infinitely many answers if you went to check. But everybody's okay? There's always been a back of the book, homie. If I do the sum of some constant, notice here, what's the variable, the index variable for this sum? Is I. Are there any I's in my sequence?
No.
No. That means that it doesn't depend on I at all. How many K's am I going to be adding up then? N of them is what you really mean, right? Because we're 1, 2, 3, 4, 5 up to N, so there's N K's. If I add K N times, what do I get? K plus K plus K plus K plus K N times. Very good. That's our formula. So if I take the sum of a constant, it's just the constant times the number of terms, right? Everybody's good with that? Let's say I have the sum of two separate sequences, and I want to do the sum of those two. Guess what you can do? Sure. As you can distribute the summation symbol. Which shouldn't be a surprise, right? Because if we expanded this out, this would be like A1 plus B1 plus A2 plus B2 plus AN plus BN. And since the only operation going on here is addition, you can take all the A's and put them together, and then all the B's and put them together. Right? Does that feel okay? Yes, go ahead. So if the sequence that we're adding up is arithmetic, there's like 3 different versions of a formula you can use depending on what you're given. You're free to choose. So the starting information will dictate to you which one is probably going to be the easiest one to use. Could you use any one of the 3 though? Yes. They are equivalent. Oh, I guess let's not do that yet. Let's do our examples, I guess, first, huh? All right, consider the following arithmetic series. Part A says write the series using sigma notation. What should be the lower bound here?
3.
Nope.
1.
1. The upper bound should be 50. What is the sequence that I need to write in here? Where is Mr. Kulik getting this? This is just the formula for a sequence or an arithmetic sequence, right? That is our formula. How did I figure out what A1 was? Well, it's literally there, right? I figure out what D was. I just looked at the numbers, right? That's it for part A. For part B, it says find the partial sum for the first 50 things of the series. How am I going to do that? I'm going to take that rectangle sitting in front of me. That's your calculator, folks. And I'm doing this thing on my calculator. I am not going to do this by hand. Yuck, Aruskis. So 6275. Oh no.
But like you said, negatives, sides of subtract.
That would do it. Everybody's okay with how we did that? Alternatively, if you wanted to use the formula, I would use n over 2. Come on. Times 2 times a1 plus n minus 1 times d. So that would be 50 over 2, 2 times 3 plus 50 minus 1 times 5. But that would give you the same thing as your calculator did. If I'm doing this on the test, would there be, or on the IB exam, would there be any reason I would want to do it by hand and use the formula? Oh man, like let me do it on my calculator. It can do it without screwing up where things go in the formula. All I got to do is type the summation symbol on my paper and I'm good to go.
I didn't get into it a lot.
Hey, for you diploma kids, this is an exam where if you can use your calculator effectively, it should be relatively easy to get like 5 or better. And that gets you a lot of leeway if you have another IB exam where you're like, well, I do not feel good about that one. Like, study for this one, just a little bit, know how to use your calculator, and you should be able to get like 5 or better here, which really helps. But if you get a 5 or a 6 or a 7 on this, boy, that buys you some leeway, right? To get like a 2 on something and still make it through with your diploma, which is really doable. It's really doable. Like you guys did pretty good IAs, right? The diploma program kids, you did pretty good IAs. You had like 5, 6, 7 type IAs. Yeah. Which are pretty good. Those are pretty good. Like I would like try to do well on the exam here and you can really buy yourself, like get some slack because it's not a super, super difficult test. It's like medium difficult. And if you can use your calculator and you know what stuff is, the calculator will do most of it for you. You can get a lot of points just by doing stuff on your calculator well. Okay. Let's do one more example here and then move on to geometrics. Consider a sequence in figure 3.8. Ugh, why? You stupid thing. Okay. F1 has 1 squares. How many squares are there in F20? Everybody's okay with how we did that? So Yep. That's it. Adding 2 each time. Is there a figure with 149 squares? If so, which one? If not, why not? So I'm going to solve that for n. Yeah, it's the 75th one. Is okay there? What else could have you done if you didn't want to do the algebra? You brute force that thing through your calculator, right? You can just keep like, yeah, 1, and then you do plus 2, and just count till you get to 149. It stinks, but you can do it that way. Find the number of squares in the first 880 figures. So that's what it's asking for, right? Everybody agree? How am I going to do that? Calculator. Because God help me, I don't want to do 180 or 880 of these things. Ooh, it's really thinking on this one, made it think here, huh? 77440. All right. Here it says figure F1 has 4 line segments. How many are there in F20? How many line segments do I have in F2? You guys count 9? I think I counted 9. So that's 4, 5, 6, 7, 8, 9, 10. Okay, 10.
Oh, stupid.
How many in the next one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's still arithmetic, right? So what's that? 118. Who's impressed Mr. Kulik can do that stuff in his head? You should be. It's not that hard. Is there a figure with 450? There is no feud between Mr. Oseki and I.
There is a feud. He created one.
I refuse to buy into any such feud.
Tell him that.
One-sided feud.
My sister, and every time you do like a simple math problem, you're like, Mr. Cool can't do that.
I mean,
And we were like, I actually bet he can do that. We were defending him. Yeah.
How did it start?
I think I was talking about.
what do you notice here?
Not.
Yeah.
You started it, Liza? I think I did.
You did.
Because it was like class, and then it was like. But he could help you with my econ.
He could, because we were like stuck here. Mr. Cool, this whole class. I don't remember what I said.
That's not,
All right. So let's talk about geometric sequences then.
I'll see you again.
I'll have to memorize this thing. You actually could. That'd be so cool.
Okay, so there's your formula.
This is not it. Oh, they're typically.
We're gonna get all these on the.
Yep. But even if you didn't remember, if you didn't get these formulas or you didn't remember them, what can you still do? Just do the summation on your calculator? Right? All right, let's look at this one here. Consider the partial sum for the first 20 terms of this series. What do you notice? What kind of series do we have here? How can you tell? Everything is times 2, right? So my series, or my sequence is that, right? So my series is the sum from I equals what to what? Okay, 220, what's it start at? 1. And the sequence inside of it should be that sequence we just wrote with an I instead of an N. Done. Part B says find that sum. What am I going to do? Type it into my calculator. Or, alternatively, I could use the formula, right? You could brute force it. Sure, that's not an incorrect answer. I think that was it. Oop, 2.5. So if I wasn't using my calculator, A1 times 1 minus R to the N over 1 minus R. If you wanted to show some work and still use your calculator, plug this stuff into your formula, but then just do it on the calculator. You know what I'm saying? It's usually not too bad. So a ball has elasticity such that it bounces up 80% of its previous height. Find the total vertical distance traveled up and down. Oh, traveled down and up, excuse me. If it's dropped from a height of 3 meters, and after it bounces for the 10th time. Okay, so let's kind of draw our picture here. I mean, if you want to do that, we can go down that road. Do you want to?
No, we don't.
Okay, let's not then. So it's going to do like one of these, right? Everybody kind of see what's happening? So this first distance is 3, right? And then this next distance is 0.8 times 3, but we have it going up and then down. Everybody agree? Gravity, what goes up must come down. So then this is going to be 0.8 times 3 times 2, but there's 2 0.8s, right? You can kind of see that. And then we'd have 0.8, but 3 of them, and then just kind of, everybody's okay there? So what is my sequence here gonna be? Arithmetic, geometric? Great. What's the R? 0.8. What's the first term? 3 times 2. This I'm ignoring to the end because this doesn't really fit the sequence because it's not both parts of it. I didn't throw it up 3 meters in the air and then watch it bounce down. It's like an extra piece that I'm going to have to tack on at the end. Now, let's be a little bit careful here. What should my first term be? That needs to be my A1, right? So the exponent here should be just n instead of n minus 1. Is everybody okay with that? Because when n is 1, it'll give me exactly this guy, which is what I need it to. Why am I having to do this? Because of this stupid thing in the beginning, not being thrown up 3 meters and then falling down. Everybody's okay with that? So there's that. So our sum then, I equals 1 to 10 of 6 times 0.8 to the I, and then we have to add on an extra 3. Actually, I'm going to write that in the beginning. Everybody's okay with that? But what bounce is this? Right? This was the first bounce. So really, I only want this going to 9, right? Sorry about that. So we get 23.93, or I'm sorry, 0.78. Or what if we think about it this way? What if we did the sum from I equals 1 to 10 of 6 times 0.8 to the I minus 1, and then we're going to subtract 3. right? We're just going to be like, well, we didn't count this one, but say we did, right? This is still our first bounce now, so we can go to 10. And now you could do it that way also. I think should give us the same answer. Oh my gosh, come on now. Same thing, right? Okay. You guys should be able to do now 3.4. One through like a million. And the review. So 1 through 1,000,002. I'll put up quiz and test descriptions here this afternoon into the OneNote. Somebody Luke, I think, asked me about. I wanted to get through this stuff and I forgot to come back and leave myself any time to do that. But I'll type it into the OneNote here this afternoon. Is that good enough?
Thank you.
Any other questions for me?
That's my job.
Whoa.
Man, I don't like to do that.
Yes, sir.
Guess what?